Hello guys. Alright, so welcome back to one of my videos on building an observatory. Today I will connect a Raspberry Pi with an Astroberry to my mount, and I will also access the Pi through my laptop. So this is one of the first steps towards automating the observatory. The observatory has been built. You can watch some of my former videos or go to my online page, starscapeexperiences.space. So this is my Raspberry Pi 4 and it has an Astroberry on it, and this is the power supply, and this is the GPS bundle, and I will use the VNC player to connect to the Pi once it's up and running. I've also installed a secondary router to extend my network because the one I have in home didn't reach as far as the observatory site. So I will then connect the Astroberry to the EQ6-R mount, and I will try to set up the connection. The telescope is not there yet. You can see here some of my other equipment. I use this for the radio telescope, it's not used anymore, and also for the all-sky camera, which is outside. You can see the cables here. This is for my security camera in front of the observatory, and this is to connect to the all-sky camera, which I'll also do. I've opened the observatory a bit today. The reason being it rained a lot and I have some water infiltrating from under the door. So I need to find a solution to this, because I do have a bit of water under all this rubber material, but that should be fine for now. Alright, so let's get started. So I will plug in. As you can see, this is an IP54 when it's closed, and IP44 when it's open. I've set this up to have some protection in case of water, humidity, and all that. So I just plugged it in, and it should power on. You can see here. This is cooled, and the idea is to have it here on the mount like this. I'll use some double tape to fix it here on this, and then through a cable, I'll run a cable all the way up there to connect to my mount. Alright, so we've got a Wi-Fi connection to our extension network, and I'm just going to use my credentials to connect via VNC to the Pi 4. This uses RealVNC. Now, I will not discuss about RealVNC right now, but the whole point is that it's more reliable than the web interface that we normally use. So this is basically my two devices connected to the RealVNC. One is the Pi, the all-sky camera. This is an older version. It's been running for a couple of years now. I've experimented with it, and an SE120 color camera, and the Astroberry Pi camera here is the one running the Astroberry software. So I will connect now and see if we get there it is. You can see my nice reflection on the screen as well. So here it is. I have also the not sure if it focuses, but this is the visual spec. So this is the spectrum analyzer that I have installed. This is a Windows software, so I have a tutorial on how to install Windows software on Raspberry Pi OS. And this is also connected to the same network, the extension network. So right now I have a fully functional and connected Astroberry through wireless, and I can use this now to connect to the mount over here. To connect the mount, you first need to power it on, and the user guide has some specifications here. Obviously I will be using the USB to control the mount, and I have the, where is it, this one, this is the cable. This connects to a car style outlet, but I've also bought this adapter which plugs into a normal socket, and then it has this socket here this is a car style socket that can be used to power this mount through the cable that it came with. Alright, so I have attached the cable, and now I need to see where this goes. Right, so this goes in here in a 12-volt DC power. You can see it also tells us how to, I'm not sure if you can see, there is a small feature here that's also mimicked here. Okay, and basically this means that it should go like this. It's in, and I'll just tighten this, and that's it. I should probably switch it to off just to be safe. I don't want to cause any issues, and this is quite long. I mean, my mount is quite high, and it's nicely, it goes all the way down here, and I will plug this here. At the moment I only have two of these, so this is for the all-sky camera, this is for the Pi. I don't need the, not the all-sky camera, sorry, the security camera, so I'll just plug the security camera out for this test. I will need an extension to support more, and what I'll do next is attach this here, and this I will plug it in this power socket, and then I'll turn it on and see if it works. Hopefully nothing breaks and I won't burn the engine. This is attached, and we already have some power. This is a 12 volts with a maximum 6 amp output, and the instruction manual tells us we always need to read this carefully, because if we feed too much current, it basically burns the engine. So minimum 11, maximum 16, and it uses a 4 amps for an 11 volt and 2.5 amps for 16 volts. So we have a 12 volt with a maximum 6. It will draw as much as needed, so a bit less than 4 amps because we have a 12 volt here, not an 11 one. Alright, so this is the mount. It's all secured, and now fingers crossed, this is the first time I'm doing this. Hopefully it will turn on and it will make some sounds. Alright, there it is. So we've got power to the mount. And to avoid any issues, I will attach this one here because I've got a long enough cable and I will protect it. And I don't want these to sit on the ground, even in this rubber pad protection, because, and not even this one, because I don't want any water. If there will be water here, or humidity, and you see there has been some small infiltrations from the rain. It's been raining heavily for the past days. I want this to be safe. So I always find it troublesome because most of these devices, including cameras, some models at least, and also the EQ6-R, use a USB Type B cable. So the Type B cable is this one, the one that's like a square. So unfortunately I only have one cable. I have another one for my scanner, but I need that for my scanner, and I have this cable. This cable came with the ASI 120 color camera, and it's been out in the open for several years, and as you can see it's full of rust. Well, not kind of full, but a little bit of rust, and has some you know, usage marks on it. It's a bit squeezed here, but I still use it for my solar feature detector using AI. Check my videos if you care to know more about that. So I will be using this cable. I need to buy another one. They're not expensive, but you know, all these devices come with so many USB types, B, C, etc, etc, and apparently astronomy loves Type B for some reason, and we'll be using this to connect the mount to the Pi. So one end goes in here and the other one goes in, well, I have one USB 1 here, the black one, and the blue one I know for a fact that it's probably a USB 2, so it's faster. Now I don't think I need a USB 2 for controlling the mount. Let's connect them. It's in, and this one goes in here. It's a little bit difficult with just one hand, so it's plugged in. So now I have a full connection from the mount to the Pi 4. Obviously I won't be leaving this hanging like this, and I won't be leaving the Pi here. I will be placing the Pi somewhere here. The GPS dongle, as you can see here, it's getting accurate GPS geolocation. And let us try to control the mount. I'm now connected through the RealVNC to the Astroberry that's in my observatory. It's a bit windy, you may hear the wind, and a few things you need to do to set up the GPS receiver. I've posted on my page about this. Basically, what it involves is the editing of this file to add this device. It depends, it can be USB 0 as well, but it depends on the device. In my case, it is ACM 0, and leave everything as is. And then basically it is all about restarting the GPSD service and then checking with CGPS the location, if it gets an accurate location. And here you can see the satellites it's using, and here you see the location, the altitude in feet, and all sorts of errors. All right, so that being said, let us open KStars, and I played a bit with it before this recording just to make sure that everything is smooth, because I had some issues setting up the GPS location for KStars and also connecting to the mount. So I would like to focus on these few issues that will surely help. So first thing, I will not go and set the geographical location here or here. I will set it up using the GPS dongle installed on the Pi, and I will start by running Ekos, and I will create a new profile, and I will call it test, and I will leave the mode local because the Pi is connected directly to the mount. So if it were remote, I would click remote, but in this case I'll just leave it local. I'll let it auto detect the Indy device server, and leave everything else as is. I will just set up some devices I have. I've not been able to connect everything, but I will just connect the mount, and then I need a guider or a camera, CCD camera, to actually run and control the mount. In my case, I don't have the guider connected yet, but I will add a dummy guider because I will use a CCD camera, which I'll do tomorrow if weather allows. And another thing that's really important is that in this profile we need to add the GPS connection as well, so it doesn't work even if the GPS is connected and transmits data, as you've seen, unless you add it to the profile explicitly. So the GPSD here, it will not work and it will not grab the data from the GPS. So that's it for the profile. So I save the profile, so you can see the profile here. This is my previous one, and this is the current one, the test. And you can see here the Indy control interface is not working unless you start Ekos. So Ekos must start before Indy, and I will start. USB 0 is the port that needs to be used. And another important thing is for EQ6-R, it needs to be set to this value. The bit rate needs to be set to 115/200, not another value. It will not work that way. So I'll keep it as serial, and I will connect all, and we should see it here. As you can see, it connected. It got the geolocation, the time, and the EQ mod is connected at this point, which is great. Now it's pointing somewhere. It's as I've installed it initially. I didn't polar align it because the weather is quite bad, and I didn't have a clear sky to polar align it. But I will polar align it and do a separate video for that, and also show you how you can control it from here. But you can check that you can actually control the mount. So if you go in Ekos here, if you go to the telescope and you've got the mount control button here, so this mount control button actually allows you to move the scope. So left, right, up, down, these are not azimuth and altitude. These are the two axes, the declination and the right ascension. So when you start clicking these, the diagonals are a combination of declinations and right ascensions. Because it's an equatorial mount, it will start moving the mount, and then you can stop it by clicking stop, and you can set the slew rate here, and you can also tell it to go somewhere to a particular target, and you can also tell it to park, and I'll show you this in a second. We will go to the observatory and try to control it as I told you. So windy, somewhat clear. You can see some stars. Everything is connected, all set, and this is my interface. Okay, and I still have strong signal from my network. It's not consistent, and then I will just use this, and then you'll hear the mount slew. The other way around. This is the right ascension, and then we have the declination. Back. All good. So this is it. This is how we set up the initial control for the observatory. Thank you. Subscribe, like, and see you next time.